so excited to introduce our guest for today. This session is our first session for Public Day, and we have with us Aaron Yazzie. Aaron is a member of the Navajo Nation raised in Holbrook, Arizona, so right here in Arizona. And Aaron currently works as a mechanical engineer at NASA's Jet Propulsion Laboratory, so JPL, you probably heard of it, in Pasadena, California, where he designs mechanical systems for NASA's robotic space research missions with a special focus on Mars. Aaron's a graduate of Stanford University and was a key part of the Stanford Native American community, serving in many roles, including staff at the Native American Cultural Center, co-editor of the Coming Voice newsletter, and president of the Stanford chapter of American Indian Science and Engineering Society. Among his many awards for outstanding work, in 2019, Aaron received the NASA JPL Bruce Murray Award for, quote, outstanding and consistent dedication in promoting inclusion and excitement in science and education, especially among Indigenous communities. Aaron, we are so thrilled to have you. Welcome.
Thank you so much for having me. I'm so happy to be here talking to you guys virtually, especially people who are from back home, from my home state, Arizona. And of course, I love my job in the field of science and engineering, so I'm always happy to talk to others that are also interested in that.
Well, this is great. It's the perfect audience for you. And again, having this home connection is just so incredible. I kind of want to just kick it over to you to just start telling us, what is it that you truly do? I know we read through your bio, but what do you do at NASA? And, what is your role about at JPL?
Sure thing. I have a set of slides that I wanted to share with you guys. Talks about what I do and why I love what I'm doing. But first, before I do that, I want to introduce myself in my own language very quickly. So Yate, everybody, Aaron Yazzie, and Ashihinishle, Torachitni Bashichin, Kiani de Shiche, Tokane de Chanela, with Agwe the Nishle. What that translates to in the Navajo language as are my clans. That's how we identify ourselves. So I inherited my clan from my mother, just like everybody inherits their last name from their father. So my primary clan is the Salt clan, which is my mom's clan, and my father's clan is Bitterwater, so that's my second clan. I grew up in Holbrook, Arizona, but now I'm calling in, talking to you guys from Los Angeles, California. That's where NASA Jet Propulsion Laboratory is, and I've been here for about 13 years, working as a mechanical engineer. And basically what a mechanical engineer does is they get to design parts, they get to work with mechanisms, invent robots. There's all kinds of different things that a mechanical engineer can do. But mostly I would say, if I were to whittle it down to what I love about it, is that it does allow you to be creative, build things, create things. And that's kind of what things like you participating in the science fair are already doing. So let me kick over to the slides that I have, and I'll show you some cool pictures.
And I'll dug out my video to give it, oh, there you go, more room. It does it automatically.
Excellent. So here, here's a side-by-side picture. And what you're seeing here is one picture that was taken by a robot on Mars and another picture taken by my older brother here in Arizona. So the picture on the left was taken by the Curiosity rover in the area that it is exploring, Gale Crater on Mars. And then the picture on the right is me standing in the desert. It's in northern Arizona, near above Flagstaff, Arizona. And you can see these two pictures look pretty similar. Stick. You can kind of see the shapes of the hills in the background, even the colors of those hills, and then how there's sort of rocks sort of scattered around the ground. It's pretty incredible that these look so similar, but they're on two different planets. Here's another comparison. So the picture on the left is me standing on a little ledge near Lake Powell, Arizona, and you can see the picture on the right is another little cliff taken, a picture taken on Mars of Vera Rubin Ridge. And those two pictures also look the same. These rocks are very likely the same type of rock, some kind of sandstone, and you can see the layers and you can see the colors are very similar. Here's another one taken near my grandparents' house on that top picture, Shadow Mountain, Arizona. And on the bottom is Mount Sharp, which is on Mars. And you can see like sand dunes, you can see mesas, black rocks, sandstone rocks. Here's Monument Valley up in northern Arizona, really close to the Four Corners. And then down at the bottom is Murray Buttes on Mars. And then here's one taken near my hometown on the right. They call that area the Painted Desert, and then compare that to Gale Crater on Mars. So I like to show all these pictures side by side to show you that Earth and Mars are really similar planets. I always say that they're related. They're like cousins. They have a similar origin story. They were created like 3.5 billion years ago in a very similar way. So Mars has a core and a mantle and a crust, and a lot of the reasons why their landscape is shaped the way it is because of the same forces and the same things that shape Earth. So like things like water, we know that when water's flowing in an area for a long time, it can create different shapes in the landscape. It can even create canyons, create craters, like things that are impacting the planet can create some things. Volcanoes. We know that volcanoes sort of bring new lava to the surface, and that can turn into rocks, and that can create new landforms. Same thing on Mars. They have volcanoes. Mars has Marsquakes, just like we have earthquakes. So the two planets are very similar. And what something that scientists have started to get really interested in is knowing that because Earth and Mars are so similar, so related, and they developed in the same way over billions of years, like what the open question is, what if Mars at one point started to develop life on it, just like life started to develop here on Earth? And so that's one of the things that I get to help answer in my role on the Mars 2020 mission. So Mars 2020 is a robot. I hope you guys have seen pictures of it. I'll show you pictures here. We're sending it to an area on Mars called Jezero Crater, which is a crater that we believe used to have a bunch of water in it. So Mars used to have lots of water on the surface of the planet. And we know that wherever there's water, there's a potential for life to grow there. And so we're sending it to an area on the crater where we'll be able to study the rocks that have been there for billions of years and might have started to grow life at one point because they were at the bottom of this old ancient lake. And we want to do that by drilling into the rocks and pulling out nice little cores of rock, saving them inside sample tubes that we want to bring back to Earth and study them here on Earth. And maybe when we study them, we can find evidence of life on Mars. So this is the part that I got to work on. It's the sample caching system, which consists of 3 robots, basically. So there's the Mars 2020 Perseverance Rover has a giant arm on the front of it with what we're calling a turret, but it's kind of like the rover's hand. It has a bunch of instruments on that hand, like a contact sensor and some science instruments and a camera. But it also has a giant drill, and that drill is what we're going to use to drill into the rocks. And so at the other end of that robotic arm is a big assembly inside the body of the rover called the adaptive caching assembly. And that's where we store the bits, and that's where we store all the tubes. So I was responsible for all of the drill bits that the rover is using right now to drill rocks on Mars. And so you can see all of them lined up here in the top right. All of those bits that you can see they're all pretty gold in color, are ones that are actually on Mars right now. And I built each one of those. And so we sent 6 coring bits. Those are the ones in the middle. Those are what we drill into rocks and get a rock core out of, very similar to the bottom right picture. You can see these are different types of rocks that we've drilled and pulled out little rock cores that are about the size of a piece of chalk. And then we have a regolith bit. That's the tall bit on the very far left. We can use that bit to get loose sand. We call it regolith on Mars. And then on the far right, sorry, one sec. On the far right is what we call abrading bits. They're the short ones that you see on the far right. And they make a little tiny short abrasion similar to the rock in the middle that's kind of gray in color. There's like a big circle. We can drill or remove just a thin layer, the top layer of that rock, and look at what's underneath and study what's there. And the sample tubes, they're down in the bottom left. This sample tube is what holds our sample, and it fits actually inside the bit because the bits are hollow. So here's me and my team posing in front of all the bits that we had just built, and we're very proud because it took a lot of work to get to this point. And we're in our clean room, and you can see we're just covered completely top to bottom in what we call bunny suits, or their clean room suits. And we had to be very careful about being super clean. That's why we have the goggles on, and that's why we have several layers of clean room garments, and we have gloves on. And that's just because we're drilling into rock. So we didn't want to accidentally contaminate anything or send something that we didn't want to send on Mars.
Erin, there's a comment in the chat here that in the picture before the bunny suits that it says the left one looks like it's wearing sunglasses, and I think that's the bit. So noticing those two black spots, and I just figured I'd call it out since someone noticed it.
That's great, yeah. So those two black spots that you're seeing there are actually the little windows where sample will fall into the bit.
Super cool. Okay, keep going.
All right, I got it. We're almost to Mars. So this is the rover finally all built up. There's a bunch of different teams that were working on different parts of the rover. So there's people building the wheels, people building the body of the rover, people building what kind of looks like the rover's head, which is actually a mast, and it has some cameras up there. And it all came together in this clean room. And I got to go in there only a few times, so that big yellow arrow is pointing at me, but you can't tell because I'm covered. Sorry, I lost here a second. Okay, a big part of my job was also, in addition to designing and building those drill bits, was to do a lot of testing. So it's really fun to be able to set up a bunch of tests that mimic Mars's atmosphere, and we bring in rocks that are similar to rocks we might find on Mars, and we just drill and we practice drilling and we figure out all the things about drilling so that we can do it successfully on Mars. And so Mars launched July of 2020. It was right around the pandemic, so we all watched from home. So that's a picture of me in the top right watching on a video conference call, very much like the one we're on right now. It launched at 4 o'clock in the morning, so I have my coffee there with me. And I got to participate in some cool media outreach stuff after that. So I was on local television and in several areas across the US. And then later, we landed successfully on Mars. So this is landing day. This happened in February of 2021. Once again, we were watching from home, but we landed successfully, and it was very exciting because that's one of the riskiest, hardest parts of the mission. And once again, I got to participate in a lot of media outreach. So here's the one that was really cool is down on the bottom right. I was actually part of a PBS program called Nova that talked about the rover. Here's the first pictures that we sent down from Mars to show that we landed successfully in our first glimpse of Jezero crater. And then here's the first pictures we got down of the parts that I worked on. So there's a tiny little drill bit inside the turret there on the left picture, and then on the right picture is what we call the bit carousel. It's the assembly that holds all the drill bits, and it's there safely on Mars. And so then the rover was able to start its mission. It started driving, it started poking around at rocks that it might want to study, started taking a bunch of pictures, just like this one, which is a selfie that the rover takes. The rover is able to take selfies. And that's because, like I said, the arm, the turret has a camera on it, so it can actually hold it out, point it backwards, and take a picture. This selfie was taken after the rover had successfully deployed the helicopter. That's the helicopter you see in the background there. We sent the helicopter to Mars, and it's the first time that we've ever tried to demonstrate that you can fly something on another planet. So that was really exciting. And so that helicopter was successful. This is a picture of it in the middle of one of its flights. In the bigger picture on the bottom, in the very edges, you can see its little feet kind of coming into the view. And then in the very top left, there's a little tiny thing that I've blown up here. It's the actual Perseverance rover. So this is a picture that a flying robot took of a driving robot on Mars and sent back to us, which is so exciting. And so the helicopter was really successful. It continued to do more flights, longer flights. And so it's done 23 flights so far, and it's going to continue doing more flights. And it's flown about 3 miles. So that was a really successful demonstration we did. So then we started moving into this area on Mars that is named Seta. And you'll realize there's actually some Navajo names on Mars. And I got to help identify rock targets and science targets in areas like this using the Navajo language. Here are our first drill and abrading events that happened. So the first rock abrasion on the top with a picture of the abrading bit there on the top left. And then the bottom right is the first rock core that we drilled. And then there's a picture looking sort of straight on at the coring bit inside the turret. And then we went on to do a bunch more. So here's some more rock cores and rock abrasions. It's just, I love seeing these images because they're so clear. It makes you feel like you're standing on Mars looking at these things. And then, oh, and here's one more selfie that the rover took. So you can see the rock in front of it. There's two little holes there. The rover just finished drilling both of those holes on Mars. And so that's kind of where we are now. We are continuing to explore Mars, explore Jezero Crater. There are pictures being sent down every single day, and you can go to that website that I put there, mars.nasa.gov, and then go to the Mars 2020 area, and then go to the raw images area. Those pictures get updated every single day. As soon as the rover sends them down to Earth, we put them up on the internet for everybody to see. And so that's where I got all these pictures that I'm showing you. And so we've been able to drive around on Mars for 395 days. Mars days are called sols. And we've driven about 4.5 miles, which doesn't seem that far for a car, but for a rover, that's a really long way to drive, especially autonomously on its own. We've collected 8 rock core samples so far. And so I think that's the last slide that I have. So yeah, that in a nutshell is what I've been doing for the past 13 years. Well, this particular project I've been working on for the past 6 or 7 years. And my new role at my job is actually to bring those sample tubes with the little rock cores inside them, working on the mission that's going to bring those back to Earth. So that's really exciting.
I'm like wowed. Okay, those images are absolutely incredible. The work you've been doing is just phenomenal. Erin, I mean, you've got to have feelings about this. I know how I feel just looking at the pictures. How does it feel to be working on projects like you're working on? I mean, working on another planet.
Yeah, it feels unreal sometimes. Like, it kind of feels like I'm living a movie. Like I'll sit in meetings sometimes where we're talking about the best way to transfer a sample between 2 robots. It's like, well, we can drive up here and we can scoot this way and use the robotic arm to grab the sample here. And it just sounds like we're playing with toys, you know? And in a way we are, like, but I think as cool as that is to help control a robot on another planet, I think ultimately the coolest thing is that all this stuff is working towards helping us learn valuable science that's helping us understand more about not only Mars, the planet, but also Earth, the planet, because like I said, they're both terrestrial planets. They're both similar planets. So when we learn more about Mars, we actually learn more about our own history, our own knowledge of how Earth came to develop into the way it is.
That's so important and so exciting. And also, I mean, by saying you're working on games, you just made gamers everywhere go like, oh, I could work in space science. So not a bad thing, not a bad thing. And speaking of working, so, I mean, all the amazing work you're doing, you've had to work very hard. We heard in your bio all the accomplishments, but, you know, can you talk just a little bit more, especially for the audience listening today, about that career path and the education involved in your career path? You know, how you got from, you know, being here in Arizona as a student to the awesome career in space science that you have today.
Yeah. So yeah, it's not a very common path for people, at least from my community. So I grew up in Holbrook, Arizona. I don't know if anybody has been through there. It's in northern Arizona. We consider it a border town to the Navajo Nation. So it's not on the reservation, it's just off of it. Growing up in a small town, we had our small school and a small public school. I thought I'd get a pretty good education there. But growing up in that kind of world, I didn't know anybody personally that had gone to Stanford. I didn't know anybody who had gone to NASA. So I didn't really consider that like something that I would do ever. You know, I didn't even consider it. It wasn't until I started to advance and go a little bit farther that I realized more and more, oh, this is a possibility. This is something I might actually be able to do. And so I would say that it started when I was in school at Holbrook High School. I made sure to do a lot of summer programs. And those took me out of Arizona to explore a bunch of different things. So the first one was an upward bound program that was held at Northern Arizona University in Flagstaff. that was geared towards minority students, Native Americans, and it had a focus on science and engineering. And so I learned more about the fields of science and engineering. I got to live away from home for about 8 weeks in a college dorm with a bunch of other students that were similar to me. They were interested in learning more about this field and sort of enhancing their education. The summer after that, I went to another summer program called College Horizons. And that is another program geared towards Native Americans. And its main purpose is to help to teach students best practices for applying to colleges and applying for scholarships. But the really cool thing about it is that it brought together the people who were teaching us. This is a group of people from all these different giant, like big name universities. So Harvard was there, and Princeton was there, and Stanford was there, and MIT and Cornell and Brown and Yale, and that's the first time I've ever interacted with people like that. It bounces around to different places every year, but that year it was in St. Louis, and so that was the first time I got to fly in a plane, like leave my hometown and fly in a plane by myself, go to the summer program, talk with people from all these amazing schools. It was actually at that program for the first time that somebody sort of like said, you're a smart kid and you're doing well and you're making the most of your education. And I think that you have what it takes to get into a place like Stanford. And so that's what kind of the first seed that was planted, the first idea that I thought that I might have a chance at getting into a place like that. And so when I was thinking about where I wanted to go to college, I applied to Northern Arizona University, I applied to University of Arizona, and I applied to Stanford, and I got into all three of those. And so I decided to go for Stanford. One more summer, my final summer in school was between my junior and senior year. I actually got to do a program called NASA Sharp. It's the NASA Summer High School Apprenticeship Research Program. And it was geared towards high schoolers. It wasn't just Native Americans, it was all high schoolers. And you applied and you got to choose a certain field of engineering that you were interested in. And they paired you up with a mentor and you got to do a project over the summer. So I got paired up with a graduate student from University of Michigan. And so I went to go stay on Michigan campus for about, I think, 8 weeks over the summer. And I worked on a mechanical engineering project, and that was the first time I got to see what is involved in mechanical engineering, the kinds of things you might do. I got to design some parts for a lab test, and I got to make a 3D model of them in our 3D model software. And so I came to realize that I really liked that kind of engineering, and that's why I chose to go into it. So after that was high school, I got into Stanford. Kind of the first, I don't know if I was the first ever in my community, but the first that I knew of, that went from Holbrook to Stanford. It was a little bit of a culture shock. It's kind of like going from a very small town, small public high school to this giant university with a bunch of really smart people in California. And so but it also happened to be one of the best engineering schools in the nation. And so I got a really good education there. I had to work very hard to make sure that I kept my grades up, kept my scholarships, that I could graduate on time. While I was at Stanford, I continued to, like I said, go to summer programs, except now, instead of summer programs, they were internships. So I applied to internships every single summer within my college years. And so my first summer after my freshman year, I got to work at NASA Goddard Space Flight Center, which is located near Washington, D.C. I worked there for a summer. The summer after that, I worked at NASA Glenn Research Center in Cleveland, Ohio. The summer after that, I got an internship actually back home. I really wanted to see if I could return to the Navajo Nation and use my mechanical engineering degree in some way. And ended up, the only one that I actually could find there was working at a coal mine. So I worked at a coal mine, mostly large scale mining equipment type of stuff. Realized that I wasn't interested in that I was way more interested in the NASA stuff. And because I had those two internships, that's what really convinced me. Like, I think I could see myself working there. It looks like I can handle the work. Like, it's not too much for me. Seems like people are nice and are willing to help me. And so I applied to work at NASA my senior year, and I got an offer.
That's such an incredible journey, Erin. And you said it's not a traditional journey. And maybe it's not, but what I heard you say was that you said yes to a lot of opportunities and made a lot of opportunities happen for yourself. And I see that in the comments over here too, with just comments on amazing opportunities and an inspiring story, because it really is. I mean, just everything that you set up for yourself, that took a lot of initiative. So that's actually a great story, I think, for our listeners today. If there was anything about that journey that you could change, what would it be?
That's a good question.
I know, a stumper. Sorry, I said no stumpers today, and here's our stumper.
Sorry, I just got something in my throat. It's hard to say because, like, in listing all the things that I had done and the decisions I made, a lot of them were things like they were kind of a risk I had to take, just like you said. Like, nobody had done it before, so I was kind of blazing a path. And in my mind, when I was applying to Stanford, it was a big risk. I didn't want people to know, because I didn't believe, like, what if I didn't get accepted and then I'm the person that tried to think that I was good enough to get into school, and then of course I'm not, so I remember being nervous about a lot of things, but along the way I ended up making a lot of really great decisions. And when I look back, I'm like, wow, I'm so glad that I did that, and I got involved in this program, and that I met this person, and that helped me realize this, and then that led to this. I think the only thing that I can point at that I might want to change is just that the whole way, like I said, I was so nervous and so scared that something bad was going to happen, that I wasn't good enough. And I think that's what I would change. That I think, because I came from a small town, because I came from this area, I felt like I didn't belong in spaces like Stanford, or I didn't belong at NASA, because I never saw anybody like me that had gone to do those things or go to those places. And if I would have earlier in my career had a little bit more confidence that I exist, that I can exist there, that I can thrive there, that those places also belong to me, I think I would have had a lot less stress along the way.
Thank you for that. And you said, you hadn't seen anyone like you, and you've already won awards for inclusion and, promotion of diversity. Why is it that representation matters in your field, in the space field?
Yeah, and I think that kind of harps on what I was saying earlier about not seeing people that look like me in those places. And that is already pretty, like I said, it already capped what I dreamed was possible. Now I'm hoping that now that I've made it up to this position, I want to wave my hands and show everybody, like, look, we belong here too. We can do this job just like anybody else. And hopefully that means that people like me, who are younger generations, can see themselves in spaces like this. And I believe that's already happening. There's a whole lot more representation with women engineers and scientists, and minority students, Native Americans, and they're all coming up through education. They're getting involved in these science fairs, and they're seeing people like me and other role models who are up there doing the things that they want to do. And engineering as a whole is becoming a lot more inclusive and representative of the entire population of people. And because of that, I want to make sure that my job, what I'm doing, welcomes them, that there's a space that they can thrive, that they aren't going to feel like left out or feel lonely, feel like they're the only ones trying to do this. So that's why I think it's very important for people like us who are in these positions to make room for them, to make a space where everybody can feel like they can thrive.
I think that's a fantastic point of view. Thank you. And I absolutely 100% agree with you. So thank you for all the work that you're doing. I want to make sure we leave some time for any additional questions from our audience today, but I do have a couple other questions for you. I'm going to lighten up a little. You talked about working on Mars, so it's got to be kind of hard to compete with, especially looking for, well, first off, you're looking for life on Mars. What do you think you're going to find?
I think it's very possible. Like I said, Earth and Mars developed about 3.5 billion years ago, and you can imagine them just one in space here, one in space here, and they're starting to develop a large a crust and a mantle, and they're starting to develop water. Mars used to have a ton of water on it, and that's really kind of exciting to think about. And so there's this watery planet, rocky planet over here, watery rocky planet over here. They're both changing and forming in different ways. Because there used to be water on Mars, they kind of believe that it used to be a lot warmer. maybe not as warm as Earth was, but in order for water to sort of be sustainable there, it needs nowadays Mars is way too cold, and they don't have a very thick atmosphere, so they kind of just lose all their water. But it must have been a different environment back then, and that environment is the kind of environment where life could form, because that's how it formed here on Earth in a very similar situation. And so whenever I say we're looking for life on Mars, I don't mean that we're going to find like a green alien with like a brain and toes and stuff. What we're mostly looking for is microbial life. So that just means the things that are very early stages of any kind of life. They're usually the kinds of things that grow in a body of water. And so by now, those things are long gone. They would have lived a life maybe on Mars, and then they would have probably become a fossil. So when we look for, that's why we're mostly studying rocks, is because we want to see if we can find evidence of a fossilized life on Mars.
Yeah, all those sci-fi movies make us think that we're going to find other humanoids out there like right away.
Right.
But we're more likely to find yeast-like organisms and octopi. I don't know. It's going to be very different. But how exciting! So, I mean, my add-on question to that is, okay, at the Science Center here, we get to learn about a lot of different projects. We have some partnerships with NASA working on various things, even celebrations like the recent James Webb Telescope launch, right? What other maybe NASA projects or other space science projects are you really excited about?
Yeah, so of course I'm excited about all the Mars stuff, and excited that I'm part of the next leg of that mission to like bring those samples back, because that's going to be a crazy in a set of missions. There's about 3 missions that are going to be involved. So first we're going to first we've already sent Perseverance, the rover, there. It's going to do its job to collect rock samples and save them in the tubes on Mars. And then we're going to send a lander next. And this lander is going to carry with it a little rocket on it with a little tiny, it's a spherical looking, they call it the orbiting sample assembly, and it's able to, you open it up and you're able to put little tubes in there. So we're going to find those tubes that Perseverance collected. We're going to pack about 30 of them inside this little canister and then put that in the rocket. And the rocket is going to shoot and launch from Mars into space. And then we're sending a 3rd mission. So it's going to get those samples into space, and it's going to be orbiting in Mars, around Mars. Our 3rd mission is going to leave Earth and then catch the samples in space around Mars and then fly those back home. And then it's going to land in the desert of Utah, I believe. And that's how we plan to get those samples back. And so that's all going to happen in the next maybe 10 years or so. I think maybe by about 2033, we'll be able to get those samples back here. So that's exciting to be part of that. Another really exciting thing that NASA is sort of gearing up to do is start to study Europa, which is a giant moon that orbits around Jupiter. And this giant moon, it's covered in ice. And they believe because it's ice that maybe there's liquid water like underneath all that ice. And so they're really curious. It's for the similar reason why they're studying Mars. They want to see if that body of water on that moon is possible for life to start to develop there. And so there are missions that are going to orbit first. The Europa Clipper mission is going to orbit and take a bunch of pictures and study that moon. And we're in the very early development of possibly sending a lander. So something that will land on that ice and then maybe do some sampling of some sort. Maybe it'll drill, maybe it'll bury something down, maybe it'll send a little swimmer underneath the water to like look at things. So that's another really exciting mission going on.
That all sounds so cool. And you mentioned, early 2030s for those samples in Mars. And if I recall, as part of Artemis, we were thinking we might get the first humans to Mars in the late 2030s. Is that still on track that you know of? And I guess a couple questions. Is it still on track? What do you think about it? And would you go?
Great question. I don't know too much about that. If their plans are on track or not. We at least at my lab, the Jet Propulsion Laboratory, our main focus or what we're good at and what we usually do is robotic space exploration. So we always send robots. And so I'm not
right before you send people, send the robots first.
Right. And a lot of the things that the technology that we need know and to have figured out by the time we send humans. We're figuring it out through these missions like Curiosity Rover, Perseverance Rover, like the helicopter Ingenuity. Like it maybe a flying helicopter could help us with humans living there. And then being able to land very heavy things on Mars is very difficult. It has a very thin atmosphere, and there's not a lot of atmosphere or wind or air resistance to help slow things down. So it's already a big challenge to send something like a big car, like a 1-ton car to Mars. Imagine also sending humans with all the food supplies they need and all the things they need to live for 2 years, 3 years. So that's things that have yet to be figured out. Would I ever go there? I mean, I love Mars a lot. I love studying it. I love taking pictures. I think it looks like Arizona. It looks like home. But I don't think I want to go there. It's a very harsh planet. Like I said, it's very cold there. You would always have to have this giant big spacesuit on if you were going to be there. You can't breathe the atmosphere. They have carbon dioxide in their atmosphere, and we need oxygen. And so to go to Mars and live there means that you're going to be living inside of a bubble or maybe in a spacesuit, which could be fun too. It would be very adventurous. But
very different, I'm sure.
Scary for me. Yeah.
Yeah. Oh yeah. We do have a question here. Where do you normally send the rovers? Near the equator or near the poles?
Oh, good question. I don't think we usually target regions of the planet, like the spherical planet. We usually try to find what's most scientifically interesting. So it doesn't matter where it's located. If there's a crater over here that once had an ancient lake in it, and it looks like that might host life, then we'll send it there. If we're going to be studying, there was a previous or a past mission called Phoenix, like Phoenix, Arizona, but it's the Phoenix lander that was going to study the poles of Mars, because they saw these white, what looked like a white substance, and they thought, oh, that must be like ice, like snow, and so they wanted to confirm. And this is before we knew a lot about the water that on Mars. We didn't know if there was water in the past, and so they sent the lander there. It scooped up some of that icy substance and realized, yes, this is frozen water, and this is water on Mars. And so that was a big, exciting discovery. So we will land a rover wherever it's interesting to study.
Thank you for that. We're kind of coming down to our last minute here, so I'm looking for any other questions from the audience. Go ahead and throw those in the chat. And while we do that, Erin, I mean, this has been awesome. And I just want to say, because you talked about hauling all the stuff to Mars too. It's like the greatest sustainability project ever thought of, right? To think about having to go to another planet to live where there's nothing, right? You got to bring everything.
Right.
So I think that's a great point. And just sounds like a crazy, like it's like a planner's dream, but at the same time, really, really hard.
Right.
So with all of this, again, your journey has just been incredible, and you've already mentioned some things along the way as far as advice. But those who are listening today are obviously interested in science, technology, engineering, and math in some way, shape, or form. Any advice for those who might want to go into a STEM career? Just simple advice.
Yeah, I think one, definitely take advantage of summer programs and internships. Those were all things that like I said, I did it every single summer from high school all the way until I graduated. Each of those things not only allowed me to explore different areas of engineering, to I figured out during one of those summer programs that I didn't really like civil engineering. I wanted to do mechanical. And they helped me determine where I wanted to go to college. They helped me meet people that are still like really good connections today that have helped me in my education and career path. So I encourage you to seek out programs like that. There's a lot of engineering summer programs that you can get involved in, but also not just in the summertime, but year round. Like if your school has some cool robotics club or something, like that's a really fun, great opportunity to get really familiar with what an engineer does, to get good experience, and people when they're trying to review your application for college or try to hire you for a job, they love seeing those kinds of things, experiences on your resume and in your past.
That's great advice, Erin. Thank you so much. And unfortunately, we're out of time to do any more, and I kind of want to just keep going. You've got such great things to share. But it sounds like we'll have to bring you back to do another session with us, because this has been amazing. So thank you so much for your time and spending time with us today. Erin, I'm like,
Thank you so much. It's a great
you're
discussion.
welcome.
Thank you so much.
Thank you all again for being here. Erin, one more time, thank you so much for your time today and your amazing sharing of your amazing story. And we can't wait to see you all next time.
Excellent. Bye, everyone.